Hi there, welcome to week 5. It's been a while since I've done one of these online video style lectures, so let's give it a go. It's a little bit difficult because I normally do this with questions to start off for you guys to remind me what this week's topic is, but obviously that kind of a joke isn't going to work here, so I'm just going to cut to the chase. We're working on systems thinking, a systems approach to sustainability. And to start this off, with the slides today, don't forget that they're available for you in week 5 in the readings folder. You go to the lecture slides and you download them there. And I think it's probably best in this format. If I don't go into presentation mode, then you'll be able to see which slide I'm up to here. So, systems. Let's start off with an old Sufi story. So when we look at this picture here, we can see, obviously, we're looking at an elephant. But so the story goes, if you're only able to see a part of this, you might look at this, and this looks like a snake. You might look at this. This looks like a rug, magic carpet or something. This looks like Corinthian columns, on the Parthenon in Greece. But of course, when you put all of the different pictures together, you're able to see what the whole is. And it's quite often the way with us that we zoom in on a particular part and try to study that without looking at the whole picture. And when we do that, we're unable to understand what it is that we're looking at. And so when you think of the way that knowledge is often divided, we divide things up into particular categories or areas of study. These are known as epistemologies. There's a term for you. Epistemologies. So an epistemology is an area of study, to study, and a particular area, epistemology. Yeah, and so we look at all of the different streams. We've got chemistry, we've got the law here, we've got the arts. What is this? Medicine, is it? Biology or something? This is mathematics. I suppose this is physics. Oh yeah, crumpled up paper. But of course, if you want to understand the way the world works, of course, all of these separate areas, they don't fit into neat boxes. They're all actually linked. I mean, it's very, very difficult to understand physics if you don't understand mathematics. There are those that say that the discipline of music assists with, certainly speak to any pianist or actually any musician that's studied formally, and they'll tell you that it is intimately related to the idea of mathematics. So there are interrelationships between all of the epistemologies, the areas of knowledge. And so systems thinking is really looking at not just one particular part, but at the interactions, the lines that cross between the different epistemologies. And so that's what we're looking at today. So we're sort of working on defining the systems already. We want to look at the characteristics of a system. It's actually pretty simple, and describe it in the context of sustainability. To start this off, I wonder, could I ask you to complete this quiz? It's at chapter 4.1 over here. I'll show you the navigation. You can go into my lecture, and over here at chapter 4.1, you're going to get a link to that quiz. There it is there. See you back here in about 5 minutes. Welcome back. I've just frozen the video on this point here. It doesn't give me... Oh yeah, it does. At 3 minutes 20, you were asked a question. I think that this frame of this video is really crucial for us to understand, because it steps through basically what the 5 stages are that we need to explain in question 4 of assessment 2. And on a deeper level, they're also the way that we can most simply understand how to unpack problems using a systems framework. We really have to remember that when we're trying to figure out problems, we're trying to figure out phenomena in the universe, or we're trying to figure out human beings as they relate within the environment. So when we're talking about norms, we're talking about the way that human beings like to relate to each other, the way they like to get things done, what's okay and what's not okay. And as a result of the cultures, the behaviours of society, societies develop policies, and governments implement those policies, and police officers enforce those policies, and corporations implement policies. And as a result of those policies, structures in society forms. And if we want to make a change in this whole system, then we have to figure out, how do we intervene? A term that we're going to find in the assignment, and which is often used with systems thinking, is leverage. That's another word for an intervention. You know, if I want to create a change in a system, I've got a couple of cogs over here, and they're spinning around. They're all interacting with each other like this. If I want to change in this system, then I need to insert a lever into there and exert force down here. Where's that going to mean the force is enacted? On this one here, in an upward way. Well, that's a piece of leverage that will affect change in the system. Well, do you know, I might have attacked this from this angle, or I could have attacked it from this angle. That's basically the idea that we're looking at with systems thinking. What is a system? Have a read of this, please. It's a short piece of text, but there's a lot in it. I'll probably be asking you this a lot. What is a system? It's more than one thing. And if you try to think in the universe of anything that exists by itself, it's actually not easy. I don't think there are many things in the system, in the universe, that operate by themselves. So a system is anything that is more than one thing, and therefore when you consider the world, you think, well, it is made up completely of systems, different systems that interact. And therefore, if you want to understand how the world works, you need to employ systems thinking. So it's a pretty universal tool that we can use. And then I think when we get down here, it states it pretty well. And in systems, the relationship among the parts matters. If elements or parts of a system are added or taken away, the behavior of the system changes. So we're not talking about static snapshots. We're not talking about things that will stay the same forever. We're talking about things that evolve. And of course, the study of sustainability is a system in itself. I'm going to go on to the characteristics of a system and to slide 17. Now, I wonder, can you please take note of this, that slide 17, this is what you need to answer question 4 of assessment 2. So next week we're going to be working on the plan for assessment 2, and you'll need to provide, you're going to have to answer one part of question 4. That's not the whole test, but so we're going to be, you'll see that there are 4 parts here. You're going to have to choose one of these parts and say, well, this will be my approach to answering this. That's a bit of a tip for you. Well, this is how you answer the whole question when you're actually writing the assignment. Determine the system boundaries. So you remember Suzanne in the video. She couldn't consider the whole of the problem. So she was looking at the problem of obesity, and she's not going to be able to go to Coca-Cola and knock on their door and say, hey, could you stop selling Coke because it's a leading cause of obesity in children, because she doesn't have the resources, she doesn't have the time, she doesn't have the money. So she needs to narrow the boundary of her study to look at things that she will have some agency, some ability to create change, some levers to pull. And then the second part of this first part is to name the variables. Now, the variables are the names of things. I guess if you're looking at the variables in food production, you'd be naming the parts of the system that are causing problems. So let's look at the use of nitrogen-based fertilizers. Well, that's a part of this. That's a variable. If you increase the use of nitrogen, then you're increasing the release of nitrous oxide into the atmosphere, and you are therefore increasing greenhouse gases. So therefore nitrogen, naming nitrogen as a variable, would be a really important variable to name. That's if you're looking at greenhouse gas emissions. Of course, you might be looking at waste, you might be looking at land clearing or land degradation, water use. There are a lot of issues. And then the second part, and so, that all of that is just telling the story. That's all visible. It's not difficult to discover that. You're able to see that part of the problem easily. Then we want to sketch the trends. We want to visualize the variations that we're seeing. And we're going to investigate 3 different ways of that: an XY chart, stock and flow, causal loop. We'll look into that in a moment. And then step 3 is where you look at the structures. This we've seen in the video. Think of structures as the legal limitations. You've got to stick within the law. When are things breaking the law? But also these might be physical boundaries, so geographic boundaries, fences, borders, and then mental models are behaviors. The American commentator called them norms. What's right and what's wrong, what people agree to and don't agree to, how we do things around here, the culture, the behavior, the habits of a society. And then finally, and really this is the reason that we do systems analysis, is to come up with, why did that just happen? The reason that we do systems analysis is to come up with suggestions for ways to address a particular problem that we're analyzing. So we want to create suggestions for leverage. All right, so let's zoom in on that. Step one, tell the story. More or less already figured this out. We've got to create a boundary here. Now, for example, in assessment 2, what we would be doing with this is saying, well, with food production, it's a huge area. I mean, agriculture is it's one of the largest sectors. Why? Because human beings can't survive without food. So it's existed ever since human beings have started cropping land. That's a long time, and it's existed in all parts of the planet. So if you want to study this, you need to create a boundary. One boundary that you have to consider, one sort of limitation you have to consider is your word count. You've got 1,000 words. How much time do you have for your study? You've got one test next week and another test, the main test in week 7. So you don't have much time. So therefore you would want to limit your discussion to something like, okay, I'm going to choose a couple of main issues: nitrogen fertilizer and land degradation, or water usage and nitrogen. You might even go into the relationship of standard farming. Do you remember we saw this in Monbiot's article, the required reading, standard farming, or it's also known as factory farming, the relationship between that and inequality. So we've got these major multinational corporations doing huge scale farming and local producers that can't compete. That's an issue of food production that is very difficult to solve. And then what are the variables? Well, really, I think that I've just been naming what the variables are. Remember that a variable is something that increases or decreases over time. And so you need to think about that when you're naming those. Just described that, haven't we? Okay, so then we've got to make the system visible. And we use these 3 forms. Well, let's dive into those. First of all, trend charts, or an XY chart. Really, that's pretty simple. A trend chart. I'm sure you've all made one of these before. You just have to get a Y coordinate. That's a quantity of something. And then an X coordinate. And that's usually, not always, but usually over time. And then it's either a fluctuational trend, or it's a trend that is a gradual incline upwards, or it's a trend that has a sharp rise. Well, that's an exponential rise. There's all sorts of ways of describing different sets of data. Trend chart. It's a requirement in assessment 2 to present a visualization of some data that you've found. But another way to present data is to think about the idea of stocks, stock and flow. When you consider anything that you've named as a variable in a system, it could be the trash that you take out. It could be how often, it could be the tram that runs so many times a day. It could be the amount of petrol that you use in your car. It could be the amount of cash that you have in your bank. It could be the number of clothes that you buy in a year. Anything you name, it can be a stock. And it can be a stock because it rises and it goes down, it decreases. So let's have a look at this. You see, with stock and flows, in this case, we got the bathtub. How do you increase the stock of the bathtub? You turn the tap on. How do you reduce the stock in the bathtub? You take the plug out and it drains away. Or you can reduce the flow, of course. Inflow and outflow. And there are, we've got bank accounts, CO2. You can consider personal esteem. How good do I feel about myself? What are the strategies? If I increase a strategy for feeling good about myself, I'm going to increase the stock of self-esteem. But importantly, related to stock and flows are feedback loops. And really this is when we get into the deeper part of visualizations, because it's when we consider the idea, in this case we're looking at bank interest. Well, I'm a lucky guy. I've got a job, and every month I'm always surprised that there's this money that goes into my bank account. I go, hooray. So the stock in my bank account increases. That's this line here. That's the weekly, the monthly wage that I earn. And if I don't spend anything, then the interest is going to keep feeding into this, because the stock will stay. If I don't earn any more, and if I don't spend anything, then this interest, well, if you look at what bank interest is at the moment, it'll be a micro amount every year that I'm earning in interest. But of course, I do spend things. There's money that goes out here as well, and so that reduces the interest amount. So you see that these feedback loops, these feedback lines, they vary according to what the stock is. There's lots of variables in this system. And it's at this stage that I ask the question, who had a look at this week's required reading? So could you please go to the readings folder? And there it is there, Higgins 2014. Could you please download that and open it up, please? And it should look something like this. Yeah, so I'm not going to read the chapter for you, but it's only short. It's about 10 pages long, and Higgins writes really, really well, Karen Higgins. I've read quite a few of the other chapters in this book, and it's a really interesting book. But I want to just show to you the important diagrams in this part here. This is what the slides in the lecture slides are based on that we're just looking at. So we've got feedback loops. We've got the relationship between cause and consequence. And then, importantly, we've got time here. What's the lag? What's the delay between the effect of a variable? What's the effect? So the video also looked at the idea of systemic structures, and I've briefly explained systemic structures. They are the laws. They like the structures create the reasons why companies are allowed to set up the business models that they want to set up. And it's why the relationship of business to government that we study, I think, in week 10 is so important for business. So they want laws, they want tax breaks, they want incentives that favour business. The issue of sugar in soft drinks has been opened up again, and of course all of the major players, Pepsi-Cola, Coca-Cola, have already been down to Canberra in Australia lobbying the government as to why it should not be legislated that less sugar is put into soft drinks, or that sugar-sweetened soft drinks are taxed in the way that alcoholic drinks are. And so if you want to consider that, then you also have to consider behaviours. Well, what do consumers want in that situation? And if you want to create a change in there, well, you're going to have to consider not just humans that live in the street, that are part of the community, but humans that work in business. That is, you need to consider that the behaviour of businesses is habitual, has its own desires, values, priorities. And so we need to look for leverage within systems. Have a read of this, please. So you can see, it's why I've put this graphic here again. You have to decide which part of the system you want to put your intervention in. And of course, each of these little parts can be zoomed in on to find a really specific place. But these examples here of a complex system, which part will you approach? So if you think of the issue of the amount of sugar-sweetened soft drinks that kids drink, like, what's the reason that they drink that? Is that the parents' fault? Should we intervene with education programs that target parents? But then you think, well, where are sugar-sweetened soft drinks available in supermarkets? Have a think for a moment. Where are they? You guessed it. They're right by the checkouts. And are they at adult height? No, they're right down by the ground where 2- and 3-year-olds can look at those brightly coloured drinks in the clear bottles and say, can I get one of those? You know, we're not just talking about Coca-Cola. Sports drinks are the same. And now we've got the caffeinated drinks as well. So it's a business model. So maybe we need to put our leverage into there. Or do we look at the legal system? Is that where do we look at the structures, the laws of the land, the policies? Systems thinking and sustainability. Yeah, so look, we're not putting an iceberg up here because it concerns water. We're putting it because it's a metaphor. It's a thing that represents systems thinking. We've got the narrative, the events of the story. So with food production, it's where we name the variables. What are they? Food waste. The use of nitrogen fertilizers causes nitrous oxide. The use of pesticides, degradation of soils, water usage, deforestation. These are the things that are very clearly a big problem, and you can list them on a hand pretty easily. But it's once you dive down underneath that you start to understand what you've named a little bit more closely. And so you have to look at the patterns of things. What's the data here? And that's where you visualize what that data is. And then you need to look, okay, well, so what are the laws? What are the structures? Things like with farming, things like how far away from the farm is the market? So if the food has to be transported 10 kilometres, compare that to a farm that is in Brazil. Like, why should Australia import oranges from Brazil when we can import them, if you're in Melbourne, import them from Queensland? So the structures, there are laws associated there, and then we've discussed mental models. And it's important to realise that the deeper under the water you go, the easier it becomes to understand where to implement your leverage. And so I guess that's the relationship to sustainability, because with sustainability, it gets a bit depressing at times because we want to be able to solve what? Problems. So sustainability is, in part, the study of problems of the planet. Well, that's a little bit useless if you don't have a way to sort of address problems. And which kind of problems? Wicked problems. Yeah, so all of this is, it relates directly to Assessment 2. And just before I finish this off, I'd like us, could we go to the Moodle and just briefly have a look at the assessment section. I want to have a look at the task sheet for Assessment 2, just to remind us. I'm going to download that so that it shows up a little bit more easily. Where's my downloads folder? Ah, yeah, there, thanks. So here we are. And go down here to part C. And you'll see here it says, using the iceberg model and systems thinking, address the wickedness of the problem. The wickedness. So up at the top here, we've asked, why is it important? Well, we've measured the seriousness of the problem. I guess that's talking about the wickedness. So you see that the iceberg model is actually central to the question that we have to answer. And indeed, why is your case topic a sustainability issue and why is it important? Well, the reason that you want to answer that is so that you can suggest leverage in this analysis here. So I guess what I'm arguing for is, please take note of this work here. All right, well, that's about all for the lecture. I guess hit me up with some questions via email if you have any. And please look out. I'm going to be making my next video that I'm going to make right after I have some dinner is going to be about how to use Assessment 2 resources. Sorry, I did that too quickly. I'm down here in Assessment 2 resources. I've loaded an outline document here, and I'm going to make a video about that because it shows you an approach to answering the questions in Assessment 2. See you all next week in person. Bye now.